Right. Welcome, everyone. This is Fred Schenkelberg. And let me bring up before I move over to today's slides, and I'm going to keep the chat window, and it will be a question and answer period coming up, or a window open you can use anytime. On the right-hand side, lower right-hand side of your screen, there's a links for more information. And just as we're getting started here, take a look at that. You can find the slides just above it, and you can also find active links to a couple other websites, to our reliability engineering webinar list, which we send out monthly, listing every source of webinar related to reliability engineering that we can find. My wife helps put that together and scours, I think, 25 or more different sources to find as a complete list as we can. So you get one email that lists a whole pile of different topics so you can plan out your next month. But thanks for joining us here today at Ascendo Reliability. We certainly appreciate it. And one other announcement before I forget is in next month, in September, the schedule that I have is just not going to let me do a webinar. So we're going to take a month off, the first time in 2 years, more than 2 years of doing this. We're going to take a month off, and we'll be back in October. We're going to do a review of the new body of knowledge for the Certified Reliability Engineering ASQ exam and certification. And we'll take a look at some of the changes and some of the impact that those changes may have, or that those changes reflect. And so look forward to that in October. We're also planning in October to launch a paid webinar program. I've got some invited speakers lined up for the next 6 months or so, and to do events that we go a bit more in depth. We'll have some more material, more how-to type stuff. Same basic format, Q&A and lots of discussion. But we're going to, since we're expanding the program, I need to cover the costs of doing this, so we're going to charge a modest fee for that, plus give those speakers an incentive to actually give us the best possible content and give them some feedback and some compensation for their time. So hopefully you can we'll take a look at that in September, October when we roll that out, and then join us for those. All right, end of advertising. Let me get into the presentation. All right, welcome to Ascendo Reliability Webinar Series. This is Fred Schenkelberg, and today we're going to talk about risk and risk management in particular. And I was laying out topics and areas that I wanted to bring up in this webinar series a couple of months ago, and I try to plan out 3 to 6 months at a time. And we listed this as risk and risk management as a topic. Now, on the Ascendo Reliability site, underneath articles, you can find a series of articles called CERM, which is a Certified Enterprise Risk Management acronym. It's managed and run by Greg Hutchinson, and he's written a number of books on it. He does workshops on risk and risk management and setting that up. And unfortunately, our schedule didn't work out to get him here today to join the discussion. But I've learned a lot from Greg over the years in order to understand how risk and risk management. For some reason, I triggered Siri there, and she started yakking away at me. Is how risk and risk management in organizations is increasing in prevalence and in different industries at different paces. Yet, as a reliability professional, we're dealing with risk in managing those risks all the time. And there's a lot of overlap between enterprise risk management and the new bodies, the standards that are coming out. And fortunately, also, the new body of knowledge, the CRE body of knowledge, has elevated risk management to its own major section. And we'll touch on a couple of those topics here today also. And so let's dive into it. Now, a quick basic definition: risk is pretty much a synonym for uncertainty. When we're not sure if this crop is going to come to harvest, or if the weather is going to support a sufficient yield, or if our product is going to be reliable enough, or if we addressed all of the latent defects that could crop into our products. That's uncertainty. We just don't know in many cases, or we know that there's possible outcomes, a couple of different ways this could pan out, depending on variables that we may or may not have control over. It's the analysis, an identification analysis of those risks is essentially taking a look at what we don't know, of revealing what that uncertainty is. And then the intention is to do something about it when we can or when we should. An example is in the product development process, or you're buying a new motor for your factory. Should I use vendor A or vendor B? Now, commonly we make that judgment on, does it have the features we need? Do they have the product that can be delivered on time, and will it do the job? Will it meet our requirements? Is it going to be reliable, or reliable enough? And how well do they know that in order to convey how it will work in our application? There's increasing amounts of uncertainty there. Maybe we don't know exactly how our end customers are going to use our product, and one vendor or the other would be better for different sets of our customers. Now it gets pretty complex. Which one do we choose? There's a number of, excuse me for just a second. I should warm up my voice, I think, more before I get started. Sorry about that. The idea, though, is that even the day-to-day selections of which component or which design option should I choose, we know that those affect the reliability. And sometimes we don't know exactly how, and that goes back to that uncertainty piece. Another more important piece that we consider is part of what I would consider risk management is those major decisions we make. For example, one of them is, do we launch or do we not launch a product into the market? Do we start production or not? Do we do a recall or not? If we're having problems, is it a big enough problem to justify a recall? Those are decisions. And as I've said many times before, is reliability occurs at the point of decision, all through the development process and all through the procurement process. And so minimizing the uncertainty surrounding those decisions has been a big part of the reliability engineering world. We want to understand the durability, its robustness, and how it fails, and what happens if it fails, are all parts of what we're doing. And to a large extent, those are all done to allow us in our teams to make informed decisions, thus minimizing the uncertainty or the chance that we make the wrong decisions. And then we have consequences that we'd rather not have. And so dealing with risk has been a part of our world all along. And so of all of those quick examples that you had, what kind of uncertainties do you deal with on a regular basis in your day-to-day work? And, is it, what kind of things do you handle or have to deal with? And I'll take a sip of my coffee here. Hopefully my voice will warm up and get going here. But please chime in on the chat window. Yeah, I like that traffic one, Jim. Yeah, key employees. I used to work on a factory as a factory supervisor. We had a couple of folks that were pretty versatile, can fill in for different people. And there were certainly a few employees that if they weren't there, our production would slow down significantly. That goes on quite a ways, though. There's things that are in our environment, and there's items that are inside our control or inside our own world, our design or our process. There's many, many others, and we'll touch on a few more as we go along. Now, I mentioned that the ASQ body of knowledge has been updated, and we're going to do a deeper dive into all of the changes in an October webinar, which I hope you can join us for. In particular, though, I was happy to see that risk management was elevated to a major subgroup within the body of knowledge, and as a major collection of tools and processes. And it had a number of additions done to it too. And that was done, the new body of knowledge came out in July, early July, and this was already on the schedule. So I tapped into that to lay out a little bit of this presentation, because I thought it was, it was fortuitous. It allowed me a way to introduce this to us and to talk about it. But basically, the body of knowledge lays it out in three different areas: identification tools and the analysis of those risks that we're facing, which will be very familiar to most of us, and then mitigation. What do we do about that? The biggest signal change in this was that it's this whole process, identification, analysis, and mitigation, is being done in the context of a larger organization risk management framework. And it's recognizing that larger framework and how we fit into that is probably the biggest change. Most of everything else is stuff that we're already familiar with. It's just fitting in with these other pieces across the organization that is formally dealing with risk and risk management. Now, the identification part breaks down into a couple of ways, but it's essentially beyond just its reliability performance. Now, we've commonly addressed safety, because this safety element of our product and how it performs for our customers may change when a failure occurs. And we often work as reliability engineers that if a failure does occur, that we're going to work with our team and engineering team such that it will fail safely. To some extent, we've also looked at economic risk. If we have a large failure mechanism or a high failure rate for our products in the field, it's going to impact the economics of this product. The warranty cost will be higher than anticipated, for example. And we can also use the cost of failure as a justification for investing in improving reliability. So that's also not an area that's unknown to us. Expand that slightly, though, into the economics of our customers and the economics of the users of our systems and also of our organization. Is this beyond just the cost of failure? Things like customer satisfaction impacts repurchase and brand loyalty. We've hinted at that in the past. In some programs tie into that as a way to improve your reliability program. It's also a risk we're facing, right? If our product has too high of a failure rate, it'll impact our market share to some extent. And accounting for that and dealing with that as part of a risk management process certainly overlaps with what we do as a reliability profession. Now, I mentioned that the big change in the body of knowledge is this concept of a risk management framework. And we'll talk a bit more about that a little bit later and define that a bit more. But first, jumping in on the chat window, I'm going to try clearing my throat again one more time, hopefully effectively, is, well, how do you currently identify risks or uncertainties would be another way to phrase it. FMEA, yeah. Design review based. I believe DRBFM is design review based on failure modes, if I remember right. I'm not sure of the preposition that goes on there. Thanks, Adam. So how do you identify risks? Failure reports, yeah, yield reports I would throw in there also, you know. Engineering judgment is another one. We're often looking at systems and it's part of the FMEA process. Yeah, the history of our performance of the product. Now, Kevin, that one of the risks there is that are we getting good data in the CMMS? Is it sufficient for that analysis? Yeah, warranty. What are our customers telling us? Yeah, all good. There's a number of different ways that we're being alerted to the types of risks that are occurring. And, yeah, and some are, yeah, Kevin, you're exactly right. The CMMS history can be better. It's better than nothing, yet there's often ways for that to get improved. All right, yeah, there's lots of ways we can find out what's going on. Some are reactive, like the CMMS history and warranty data, and some are proactive. FMEAs, engineering judgment, risk analysis, or hazard analysis, tools like that can help us to think through all the different things that can occur or could occur. Not all of these deal with the external risks. Sometimes we're focused on a design, yet how do we, in FMEA is one tool, but thinking through the variability of how our customers use the product and the environments they're dealing with. But there's also market risks. There's also competitive risks. Those elements that get incorporated into it may or may not overlap directly with reliability, yet those kinds of decisions and discussions should be occurring within the larger risk management program. Yep. Exactly right, Kevin. Fault tree analysis is another tool that we could use. Yeah, is to start looking at it. And many of these tools start overlapping with what we would call risk analysis now. Now, one of the areas of the new body of knowledge is now termed risk analysis. In it, bundles the list that's on the table here. So a handful of tools, and system safety, which is in and of itself a whole series of tools and concepts. The gist of this, though, is in some of these overlap with identification, yet the gist is to prioritize. There are many, many, many risks facing our products and our organizations. And we're just not able to address all of those. And so FMEA is the classic tool. So let's get the ones that happen that have the highest severity, that have the least desirable effect when it occurs, or consequence when it occurs, and the ones that happen most often. Oftentimes, those are become the ones that we just have to deal with. They prioritize what we work on. Now, FMEA is not the only way to prioritize and focus on what we work on. These other tools all have a role in doing that. Now, risk matrix is similar to a hazard analysis, and I'm not going to dive into details in each one of these today. Yet this is the kinds of things now that are being bundled together as a group called the risk analysis area or tools. And so I believe most of these will be familiar to you. So of all of the uncertainties that we face, how do you, and I imagine this is going to be FMEA, but chime in on the chat window, how do you prioritize your risks today? And is it working? Are you addressing the risks appropriately? Or are you identifying and dealing with the ones that you should be dealing with? Or are you still surprised? Do you still have issues with your reliability program that you should have caught? And Dennis, your focus on the change in prior problems the change is often a signal. I often call those red flags. Is a new vendor, a new design feature, a new assembly process. a new customer base, those things often trigger areas that we try to identify and prioritize. Yeah, cost versus impact. We're often constrained, as you're pointing out, David, by cost and variety of other resources. So it's some things you can do something about, and others you can't. And so you may can't use multiple elements to prioritize what you work on. Yeah, hazard analysis, Frederick, is a great tool. It's sometimes it's a subset of FMEA. It's similar in practice, yet it asks a different set of questions. And oftentimes, so it's similar yet a little bit different focus. I like that. Yeah, agency. Mike, I'm not sure what you mean by agency is asking for. Is that like the regulatory bodies, those kinds of things? FDA, okay, yeah. So they're just now the agency? I feel an overtone of the Matrix coming on here. Okay. Yeah, the risk priority numbers, and a number of you have mentioned FMEAs is a way to do this and work on it. Yeah. And it's not perfect. There's a lot of risks. And I think if our identification process is working well, we uncover all of the ones then to address. And then it gets basically put through a filter as which ones are we going to do something about and to minimize or mitigate or avoid or whatever. But that's usually based on this analysis of, well, which ones are important, however we as an organization define that importance. And that's not perfect either. So there's risk in our system of identifying risk management, or the process of dealing with risk management in and of itself. And we can get better at it, just like we can get better and improve our effectiveness of an FMEA process. Now, the last group that the body of knowledge puts us in is very short. It's only one concept really that's put in there, and it's called risk mitigation. And digging into some of the work and literature on this, it's basically, what do we do? How do we deal with this? Now that we've identified a risk, we understand it to some extent, that so how do we either just cause the risk to not go away completely? So in an FMEA, we design out the feature that would cause the problem. We just the cause altogether. Or we minimize the severity of the consequence. So if the failure is going to happen, let's make it fail safe, or let's set an alert or an alarm on it so that we can interrupt that process and not have the consequence. There's a variety of things we can do to mitigate things, but think of it as the step that we're doing to deal with the identified high priority risks that we need to deal with. And again, there's lots and lots of ways this can happen on the ground. It's a matter, though, of, is it effective? Are we doing the right things in order to make it work? In the body of knowledge, it talks about focusing on things that we tend to deal with already, is safety, liability, and regulatory compliance. Now, what's missing from that is customer satisfaction. I think we should address and deal with risks such that the product works as intended, enhancing our customer satisfaction. Yet I think the lower threshold, though, that we have to do is appropriately stated as the safety, liability, and regulatory elements of it. And yet I think we can expand that in order to improve our programs also. So this might be a rhetorical question. Is it possible, right? Can we deal with all of them? Probably not, right? I think this one doesn't need a lot of discussion. And so this whole step of the analysis part is driving towards understanding the risks or the uncertainties we have. And sometimes we need more data, sometimes we need to run an experiment, sometimes we evaluate it, sometimes we monitor, and sometimes we just accept it, that it is a risk that St. Helens up in Washington State blew its top some 20, 30 years ago as a volcano, and maybe it will erupt again. And we're not going to do a whole lot about that one way or the other. It's going to do what it's going to do, yet that is such a remote risk that we may choose just to accept that if it happens, that's what's going to happen, and move on. Other types of things, though, if we're putting sensors on that mountain in electronics boxes, we could mitigate some of the risks so that we get sensor data, we can deal with seismic shocks, it can operate as hardened to some extent if it needs to operate into the and take sensor data as the eruption occurs, things like that. We can understand the changes in the environment and then take steps to deal with that. So yeah, it's not always possible. There's still going to be a bigger, badder uncertainty out there, as bigger, badder consequence out there. May 18th, 1980. Wow, that was a while ago. Thanks, Kevin. My parents and grandparents lived up in that area up near north of Mount St. Helens quite a bit. But they had ash, and they were about 150 miles away. They had plenty of ash at their spot. One of the risks one of the consequences of the explosion was volcanic ash accumulating all over the place, which caused problems, obviously. Yeah. So let's back up a little bit, and I mentioned this reliability management or a risk management framework. So as a reliability engineer or a reliability manager or somebody concerned about reliability in general, what's our role? What do we do in this realm of a risk management framework or of a risk management process? Right? Now, some of this should be pretty obvious, and you may be actively involved with it already as we start shifting our terminology across a number of different industries into something called enterprise risk management. And we'll define that in a moment here. But this is just a setup here to think about, well, what is it we do that deals with the larger organization processes that deal with risk? And to some extent, we're already doing that. Now, the ISO 31000, a number of years ago came out, and it's a very short standard, and there's been books and books written about it, and there's all kinds of information online about the ISO 31000 risk management framework and what that is and what it means. In its heart, it really is just a plan, do, check, act. I think it's called a Deming cycle, or I think that's right. Yeah, you're exactly right, Dennis. Great minds think alike there, I guess. Of how to create something. And I think the folks that wrote this standard may have attempted to write a procedure to say, here's how you manage risk. And then quickly realize that every organization is different. Every industry has its own sets of constraints and priorities and so on. And the cultures are different. And so what they chose to do is use the word framework to create a scaffolding framework for the elements of what would make a good risk management process that you would implement with risk in an organization. And it's not like ISO 9000 or some of the others that you can be certified to. It provides guidance, and it's although I've heard of organizations that are being certified that they have an adequate risk management process. It's not the norm. ISO 9000 certification, if you're in a factory setting, is pretty common, but the risk management standard, the ISO 31000, provides just a guideline, basically, or a structure of which for each organization to build their own risk management process. And it starts with really management buy-in. And so many of our different programs and systems deal with that. And In this case, it affects decisions at the highest level of your organization, right? Do we do a recall or not? What's our appropriate approach for a major incident that occurs with our product? And it may be a reliability problem. How do we handle a spike in the warranty data? How do we deal with the different types of failures that may occur within our products? And so you start seeing some of the overlap with reliability, but it goes beyond that. The larger risk management framework would also deal with competitive threats and risks, market changes, disruptions through supply chain, and all the other elements that present risks to a business or an enterprise. And so good parts of that, though, we deal with, and we have to fit within as we work into the reliability realm. So Plan, Do, Check, Act is the basic structure of this. So first of it is just design your own process. And there's a number of elements that go into that. And actually, I was hoping to get an article finished today to post up onto Ascendo Reliability under the CRE preparation area that defined more of these in more detail. I haven't quite got that done yet, but it should look like most other business processes. There's roles and responsibility, who's going to talk to who, what are the triggers that alert more notification to other folks, how are we going to monitor this and review it, what's our process continuous improvement triggers to make this happen. And then within it, steps 3 through 6 should look pretty familiar. Is how are we systematically identifying risks? And then what do we do with those? How do we analyze those things? How do we prioritize what we want to work on? So the analysis and evaluation part goes into it. And more than a reaction plan, Dennis, it's also looking forward. What are the potential risks that we're dealing with? We do that in FMEA, right? We look at, here's a new design, what could go wrong? And then we do the treatment. How do we deal with those risks? How do we reduce that uncertainty? And how do we avoid the unwanted consequences? So some of this should look very familiar to what we do in reliability already. It's very common structure for a business process of all kinds. The product development process may have all of these elements in it. It's just structured around the steps and the major decisions we make as developing a product. Now, in the product development process, for example, or creating a new product line on a assembly line, we often look at what could go wrong, what are we going to do about it, and how do we deal with it? And at different stages, it could be at a very functional system level element, and in the detailed design, it obviously then is into the details. So the Dennis, what's an FMA? I think you're referring to something that used to be used. Oh, okay. Looking at your history, prior stuff. Yeah. I think I would have called that like lessons learned or bringing that forward and so on. But there's a number of ways, and we talked, a few people chimed in on how we identify risks already. Well, part of developing a risk management process is create the structure first. There's the planning part. Who's doing what, when, and what tools are we using? Another part of this is then actually do it, implement it. And so things that are elements of that is, well, what's our strategy, policy? What are the detailed plans? What tools are going to be used when? Who's involved? Who knows about it? Who are the major decision makers? Who are the people collecting and providing information about identifying risks and so on? In the reliability world, we would fit within this larger risk management framework because we're often the ones identifying how our products can fail. We're running halts, for example, to expose weaknesses in products and systems. We're facilitating FMEAs, for example, to help our teams prioritize which elements of the design we need to improve to minimize the risks of failures. But part of this risk management plan is then also to make sure that the process itself reflects the benefits of doing this. And I think that's a little bit different notion than what we typically have done in the reliability world. Now, I have found that really good reliability programs articulate the value they provide. They help the organization understand why we do what we do in reliability engineering. I think they're building into this risk management plan why we identify, analyze, and mitigate risks and the benefits for that. To summarize, what I think the major benefit is that we make better decisions. We avoid making mistakes more often if we think through what are the potential risks and then what can we do about those things. And in some cases, it's also, I think Dennis mentioned it, is this a reaction plan. If this trigger occurs or if this failure alert occurs or we get a report that indicates an unwanted consequence, well, what's the response? What do we do then? And that's important to think through prior, especially for the major downsides of consequences, is so that it's already thought out. We already have a script that gives us a guideline of what to do next. How do we deal with that? If you're working in a plant that has hazardous materials, you probably have an emergency response team that's trained and deals with knows exactly what they need to do. And it could be for medical emergencies of your employees, or it could be dealing with hazardous materials. Not thinking through, well, geez, do I need a hazmat suit or do I need a respirator or not? That's all pre-done, planned. And then the implementation part is you pull that out and just use it. And then it's let's monitor this process. So just like any process, right, from a piece of equipment that we're doing process control on to a business process, all the way through is we're almost always looking at what do we need to monitor or measure. How it may not be as formal as business objectives translated into key performance indicators and so on. It may fit well within that program. It may do that just fine. But it also is just the generic process of set yourself up to monitor and measure what's important for your risk management process. And from a reliability point of view, it's those unexpected failures in the field is kind of our lagging indicator that something got through our system that we didn't expect, right? And what do we need to do different to the process of identifying and or addressing those risks, prioritizing those risks, such that we would have dealt with it appropriately in our next design, or that we do it correctly next time. So it's a feedback loop, the check step in the PDCA. And then it seems to be pretty much a standard in ISO standards to do, and it's also a key element in the PDCA, is then look to improve it. Are we catching everything that we should catch and address? Are we dealing with risks appropriately? Are we minimizing what we should? Are we averting or avoiding problems when we should? And is it economical? Is it worth the effort to do this? Right? If we spend $1 million identifying and analyzing and mitigating a few risks, but we only save $10, maybe we should have just accepted the risks in more cases, knowing that we can't accept or can't deal with all of them. And then I think when you know it's working is you're rarely surprised by reliability problems. right? The design for reliability process works, that the elements that we're dealing with in the dealing with the high priority risks or in a hazards analysis or FMEA is effective. Those kinds of things all help us to improve our reliability program, but it's also now part of a larger risk management program. Are those the right tools? Are they implemented correctly in fitting in with the larger set of risks that the organization faces? Yeah, and Dennis, you're exactly right. I think one of the risks that we face in organizations in generically as reliability professionals is we don't like talking about failures. Now the marketing folks that's just not in their DNA, right? They say, no, 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 it works, it works, it works. Well, we know that's not always true. And by exposing it and talking about just like an FMEA, right? Sitting down with a designer and with a couple of folks telling them how bad his design is kind of harsh. Yet it is so valuable to think through and understand where the risks are, where the uncertainties are. What is the actual failure rate? What are the ways it can fail? Will it feel safe? Those are all important things to deal with. Now, elevate that to a risk management framework where is our set of tools and policies and techniques that we use, is it effective at identifying the right risks and dealing with them appropriately? And so how do we improve that business process of risk management? And so, yes, I'm trying to catch up with Dennis. You've got a great number of points here. The idea, though, is that it's another process that we're dealing with that is now got another set of language, things like risk profile, risk tolerance, and so on. The idea is that should exist to some extent within every organization. And the more formal it is, the more pronounced it is. In some industries, it's more adopted than others. I understand in government organizations, at least in the U.S., it's being mandated that you'll have a risk management process or risk management framework in place. And so we're seeing more and more and more of it, which supports a lot of what we do in reliability engineering already. So I don't think it's a bad thing at all. Yeah, and Mark, I'm trying to catch up. It's well, I think a huge uncertainty is in the supply chain and getting good information. It's obviously not a good way to find out a component fails is having your customers tell you. But the idea of is that something we need to deal with? Do we need to train these critical suppliers on how to get the information we need to judge the reliability of their components? Or do we test that internally ourselves or evaluate it ourselves? That would be a way to identify and mitigate that risk is, yes, that's an issue and we got to deal with it. So it's part of something that's already at a level in our organizations. Many of us already do something like that, but now it's fitting within a larger structure that in some organizations now have a chief risk officer, CRO. I don't know how many organizations have that, but I've seen a few of those titles on occasion on LinkedIn. So let's start with just the risk policy. Does your organization have such a document? And is it something that ties into your reliability program? This one's not a rhetorical question, but if you're not sure, it might be something to go check out. Go find out if there is a policy out there. Maybe there's a reporting channel that you and your organization have to tap into or tie into in order to improve that larger system. So do you have a risk policy? So it doesn't tie in. So Frederick, I would explore that a little bit as to, because there's such, in my mind anyway, there's such a direct tie-in for product reliability or system reliability to the organization, the risks an organization faces. So that might be a place to explore that and see where that connection really should be, and what inputs you may have into that program. All right. So my last part here is just a recap of the ways that risk and reliability engineering tie in together. And so I have plenty of time for questions today. And I know there's way more on this topic, and I'm going to be writing way more about it on the Ascendo reliability under the CRA prep section, since it's a new section for the body of knowledge. Well, let's take a look at some of the connections here. We identify reliability problems. It's a feedback mechanism we provide the design and development team. We also help identify problems with components and suppliers for vendor selection in some cases. When and where we can be connected into the specifications and the development of a program, even to the tolerance limits or tolerance settings on our drawings, those all can tie into identifying where the problems are going to be. You know, if we're designing a very tight tolerance on a part, and we know that the process capability for that vendor is very poor, we know that we're going to have yield and or reliability problems. It's just a simple example of one of the things that we're often tied into and connected to. We're often asked in the reliability world to create estimates of our future reliability performance, reliability predictions or estimates. Those in and of themselves are fraught with lots of uncertainty. We're projecting out into the future, and we don't always know exactly how our customers are going to use it, and what environments, and how often, and all of those factors play a role into this. But also how our components and materials and assembly processes and the variability that's in those is how's that going to manifest in those different environments. So in that process, though, we often are looking for where we can improve reliability, where we can identify issues. HALT is a classic example of that. Right. So the idea is that when we set a reliability objective for a program and then start monitoring and estimating and looking for those things, we're often doing a risk analysis. Now, we may not have called it that, and yet we're probably tied right into a larger risk management program. At some point, the team is going to have to decide, are we going to go to production or not? Or is it reliable enough? And we're tied into that decision with a lot of the work that we do. Yeah. Now, Dennis, sometimes out of specification, and I suspect you're in a medical area, I think you mentioned FDA earlier, might be out of compliance, but things like radiated emissions, it may not affect the performance. The customer may not recognize that we have too much radiated emissions, which violates, say, an FCC regulation, unless they have the interference that causes a problem for them. Then it is a failure. So I've regularly stayed out of regulatory areas and compliance areas because sometimes they make sense and sometimes they don't. Sometimes they help us in the reliability world. Sometimes they're at another constraint. Yet there are times when we have a problem of component variability where it just, the variability adds up to create a problem for the reliability, the performance of a product, and thus a reliability issue. Lots of variabilities here. Lots of uncertainty would be the other way to phrase that. Now, what we do is often design for reliability, working in close cooperation with the development team, the design team, to proactively encourage a robust and solid design, taking into account what we know and don't know, but also working with our vendors is another key example. Looking at improving our process capability. How can we make our execution of the design more robust, more consistent? And so that's just two examples. We do obviously lots of other things, but those are two ways that we take action to mitigate the reliability issues that occur. And many, many more exist there. Now, sometimes we don't get what we intended, right? And sometimes it's good. A slice of cheese on a piece of bread is actually a happy coincidence, and at least the way I think of it. But sometimes it's not the right consequence. And so thinking through, I think it was Dennis mentioned a reaction plan. It's also part of our mitigation. What are we going to do if a failure occurs? What's the plan? So at the higher levels, it may be the warranty policy and the execution of a reverse supply chain to bring products back and do failure analysis. During development, it might kick off a root cause analysis to understand what we can do in the design to address that failure and either eliminate it or avoid it altogether. But thinking through all of these steps, from identification to the steps we take to analyze and understand the risks that we're facing, and then what do we do when a failure occurs, are all part of a framework of dealing with risk in general. And so it's, like, as I've said a couple of times, a lot of this is very familiar to reliability engineers and professionals. It's a little bit of different terminology as we fit into a risk management framework. So this one you may not want to share because we are an open forum, but think through, what are those reliability risks that you're facing that your customer will tell you about if it doesn't meet their expectations? Now, it could be safety related, it could be economic, it could be brand loyalty, it could be just the types and number and nature of the failures that you need to address and identify and design out during the development process. It could be lack of availability. It go on and on and on. There's lots of risks associated with creating a reliable product. To a large extent, what we do is fit within this larger framework in order to basically understand, identify and understand, and then do something about those failures, which is primarily in this implement the risk management process. But now we've got these three other blocks that we should be concerned about. And is there a larger system, or should there be one, which many would advocate there should be? And then the various ISO standards are all heading that way, it seems like. And then how do we feed forward and improve that overall process in order for us to minimize the risk of an unreliable product? It's kind of the quick summary there. And so this is on one of those rare occasions where I actually hit the last slide before time drops out. So believe me, that wasn't planned. It just kind of happens on occasion that I finish on time. But lots of comments in the chat window. Let me catch up a little bit with that. If you've got questions, there's a chat window right now is the best place for it. Let me see. I think I have a conclusions layout. Let me change the layout slightly and add the Q&A slide there. Frederick's got one question I think I addressed. But if you got a question or if you have a comment or stuff, and I appreciate all of the comments that have come in so far. Lots of ways to think about this. So let me know, would you like more information on risk and risk management and these framework concepts and the different terminology? There's a handful of articles up on the CIRM Risk Insights article series that Greg Hutchins and a number of other authors have provided us under Ascendo Reliability. I've written a couple of articles under the CRE Prep article series and expect to have another few of those focused on risk here going forward. Yeah. Rupesh, that's, your question is probably a whole other topic, is on software reliability. I agree it's a growing area of concern as there's more and more software in our products and systems. I'm hoping to get either a couple of different authors that are pretty prominent in the software reliability area. I'm hoping to get them on Ascendo as regular contributors. It's not an area that I'm an expert at, I'm familiar with, so I don't feel like I guess, Rupesh, my answer is stay tuned. We're going to come back to that topic, and hopefully I'll have somebody that knows way more about it than me talking about it. Yeah, it's in a growing area. I think it's been around for quite a while, but now it's such a high proportion of the functionality of a lot of our products that we have to deal with it. Yeah, and Dennis, I saw your comment on the Taguchi loss function, and the concept that getting our processes and systems centered and on target has the best possible outcome and minimizes the loss, as Taguchi defines it, is the loss to society. It's if we have a failure and it goes in the junk bin, we lose those materials. We lose the value of that production of that material, but we also lose the functionality of that product, the desired outcome of using a particular product. And so we use the return on that, and it expands out from there across as a societal loss. And so in some cases, when our products fail, it's inconvenient for our end user or customer, and it may impact the society minimally as compared to other types of products and systems and failures. So it's thinking through the larger impact, not just the hit on our warranty price, but the larger impact across the society. It should be a factor of what we consider. Good point. I often ask, what's the cost of unreliability? Most people point at warranty or repair costs, the maintenance costs, for example. And that's one piece of that. It's also oftentimes, if you're pulling in design teams to address field problems, you're diverting their energy from creating new products, which is what they're supposed to be doing. If they would have designed it correctly to start with, they wouldn't have to redesign it after it's been fielded. And so it's a rework process, and it's technically a cost of failure. We often don't capture that. It's not part of warranty, yet we often have to pay that cost. And that's just one example of the many ways that a reliability problem or a failure can add up as cost, both internally and externally to society. Acceptable risk. Now, Kevin, I hadn't thought of that. That's a good idea. Let me make a note and add that to it. We make those decisions. We have products that can cause significant damage, and if and when they fail. It's a matter, is it appropriate? I think of an escalator in general. It's a heavy-duty piece of industrial equipment when you get underneath the treads of those things. And if it fails, it can really hurt people. Yet, the frequency of those injuries due to escalators is relatively small compared to the value that it provides of transporting people between layers or levels of a building, for example. And so it's that calculation. I don't know whether it's deliberately done or not, but we do it as a society. We're going through that now with self-driving cars and drones. Are the consequences of failures of those systems, or even just the operation of those systems from a privacy point of view, are those acceptable? Is those risks worth the convenience of getting your cup of coffee without having to drive to Starbucks? Yeah, Mark, you're exactly right. Sometimes laying out the details and showing the consequences, the impact of that, especially in dollar numbers, can be an eye opener. And I think it's prudent to do that. Informed decisions are much better than uninformed decisions. Um, sounds like something I should put on Twitter. Yeah. Now, Dennis, on the safety type stuff, I think many organizations use a whole different criteria to make those decisions. And they still got to make the decision, and probabilities and test results and so on is part of that equation. It may not be. Yet money, constraints, perceived value, benefits, all of those pieces start to play a role in it.